rerun the analysis. Like I said, there are only 2 more cases to do. So this time I will call it still a high quality. I will still use high quality, but I will be using now the fine mesh, which is the best mesh that I can get using SolidWorks for the entire part. So let's do that and say OK. Now again we go on to the mesh tool. We again remesh it. Again we say yes, we don't worry, we will rerun the analysis, and here I move this to the fine side. Now you can see immediately the size has become the smallest, which is around 2.1 mm on the edge. So I'll just say OK, and this time you can see it has clearly taken a bit longer to just mesh the part, but now the mesh size is very, very small. Let's actually see how many equations it will need to solve. So if we go on to the details, we can say that the total nodes number has become 80,860. So now basically the software will need to solve internally 80,860 simultaneous equations to basically get its results. So I will note down these numbers. So the nodes are 80,860 and the number of elements is, I think, 60,000 something. It's no, it's 54,689. So 54,689 elements. Let's now first look at the results again. Oh, let's run the analysis before looking at the results. So run this study, and you can clearly see that the software has started struggling a bit. It's taking around 6 seconds to solve the problem, which was previously taking less than a second. Okay, so now again for you this increase right now you will not feel it, but think about it again for a big Boeing part. This was, this is just a small, a few part. If a Boeing wing with hundreds of these kind of notches, if you're trying to simultaneously solve it, it will become a big issue. In the old days, even this sort of size, if you were try to solve it on a PC, would take you at least 20-30 minutes to solve. Okay, but obviously now the computation power has become much more than previously, but still we have to be careful about these mesh sizes. So the next approach that I will actually be showing you will be how you can have the mesh refined in a controlled manner so that you don't have the same mesh size throughout the part, because right now you saw that the mesh was, all of it was very small, but you did not really need that small mesh in the rest of the part. Anyways, before we go on to do that, let's first of all compare the error in our analysis. So let's see the stress values. So the stress value, max value, has become 177.18. So this has become 177.18. The minimum is minus 4.88. Okay, and then the gross stress value is 55.01. So you can see there is very little change in the gross value, but there is a significant change in the net stress. Interestingly, the the max stress has actually become higher now, the value than we calculated from our stress concentration factor approach. So this demonstrates that now your FE analysis is calculating the stresses very accurately in that highly refined zone. We will also look into the displacements in this case. And the x displacements you can see is now the maximum value is 4.815, so which is still higher than the previous cases. So this is 4.815 e minus 2 and Let's compare all the numbers and see the percentages. Okay, and you can see here, interestingly, now the error, apparent error has increased. So now my question to you is, would you believe this study or the one which was before it? Which you think is more accurate? Right? Why this one? Because here we are in our hand calculation results, remember, we only read the value approximately from the chart, right? If we were to use a more, if we were to use a more carefully plotted chart, then maybe our stress concentration factor value from the chart could have been slightly higher. And if it was even slightly higher, in this chart I'm talking about, right? So we only visually just looked into this and we read this. Even if it was, let's say, slightly higher to 2.1, we may actually see the stress numbers being reported here as the highest one. So I will actually trust this one the most rather than trusting my hand calculations in this particular case. But for most practical purposes, both of these will be acceptable numbers. Okay. Let's now look into the final case, because the drawback of this approach, like I said in the start, was if you're using a very fine mesh in all the zones, then you end up with a very large model, which may become very difficult to solve for large parts. So to avoid that, we can use a strategy of mesh control. Now again, different softwares give you different ways of doing it. We will see a very simple approach that we can use in SolidWorks. So I will again save my analysis file, and I will now copy my study again. In fact, before I start copying it, let me just rerun the recording.